Hi everyone. Right now I'm going to go over a project I did back in high school and see if we can rewrite this in some way to improve on and maybe make it well written. So this project is a poem generator, and you can see that my README is practically non-existent. So let's hop into the main function to see what's actually going on here. Um, what we are doing is generating poems of some arbitrary length, and the data source is Shakespeare's sonnets. And we're generating these poems by modeling Shakespeare's sonnets as Markov chains, where we predict following words given previous words. It's kind of like a proto version of machine learning, nowhere near as robust, nowhere near as complex, but has similar motivations. We are learning from previous patterns and trying to create novel data of our own. So looking through this code, you'll notice a few code smelly things, right? Blocks of code that are entirely commented out, as you can see here. Code that doesn't do anything, completely unused throughout the project. So what I'm looking to do today is re-implement this in a more idiomatic Python way, rather than how I had written it back in 2017. So what we're going to do to get started is I'm going to go ahead and open up a terminal and hop into the YouTube directory so it can get cloned somewhere. You can see we are in an empty directory right now for the poem rewrite, and let's go ahead and clone this entire repo in. Excellent. And then we'll hop into that directory and open VS Code. Alrighty. So like I said, we have the poem generation, the collection from the downloaded poems. We generate a frequency dictionary from these poems, and then we go ahead and generate the poems. So first let's look at the implementation for concat_dir poems. This is just pretty long. Fortunately I have a doc string. Takes an input directory, returns a concatenated string containing every text file in the directory. I have some explanation. Looks like I have Mac specific stuff back when I was on a Mac. And we get out the list of files. We get out the list of poems. That is good. And then we generate a frequency dictionary off of all of the poems stacked on top of each other. Back in here, you can see that we do some form of tokenization where we break up the word, we remove some unnecessary characters like commas and dashes, we break on new lines, and we try and find things that are hard stops. Someone who is more into language and grammars might form a more comprehensive list of hard stops, but this looks like what I came up with, and some special hacks to address occasional off things that appear in the data set. And it looks like we then generate our frequency dictionary like that. I have the first chapter of Moby Dick over here as some testing data, and then let's see what else. Then we generate the poem off of the frequency dictionary. Follows some rhyme scheme, which I think I abandoned in this part of the project. Provides syllable list string, which I don't remember whatsoever, but looks like something. And then frequency dictionary, which is effectively the way that we transition between states. And you can see that I tried to use some library called pronouncing, but I don't think I actually end up using it. Yes, you can see that all the code that references pronouncing is cut out except here. So maybe we do look for rhymes, but I'll probably cut that out during this iteration of the implementation because if I recall correctly, it didn't work too well. So yeah, that's the code right there. So what we're going to do is I'm going to actually close VS Code real quick because this is my fastest way to hop out a directory. Open up VS Code again, in the parent directory. Alrighty, so that's our original poem generator, and now we want a new folder underneath, poem rewrite. And you can see the first difference is I'm naming my directory using snake case, and I'm probably going to be naming everything using snake case as is Python style, rather than camel case like you see me doing over here. So the core things that we want in the project is, well, we definitely want a main file to actually execute our code. So let's go ahead and drop in main.py. And our general format is going to be 1, collect poems, 2, analyze the poems, and then last but not least, generate a poem. So let's first see how I collected the poems in my original project. Not in here, here we are. So what I do is I'm making a request to shakespearesonnets.com, and I reference the sonnet. So let's copy this, hop over here, and oh, I already have it open. So this is where I source Shakespeare's sonnets from. You can see the sonnet is provided here in some fancy text. When we inspect the HTML, you can see we have some stuff around here, right? And that stuff is effectively what I try and chop out over here. So this isn't too particularly robust. Maybe we could have navigated the HTML tree using Python HTML libraries, HTML parsing libraries, and I think I'll take that approach this time around. But the key thing to grab is the base sonnet URI, because this is how we're going to get all of the sonnets. So we're going to go ahead and swap over to here, and we'll say base sonnet URI is this string right here. So this is our baseline string for getting the sonnets, and notice we'll be adding some number here, but we don't have that added yet. And of course we'll start moving things progressively out of main into helper files to make sure the code stays clean, but I like developing against main and refactoring out continually. So we have our base sonnet URI. We're going to use the request library rather than URL lib to get the sonnets. So let's go ahead and import requests, and let's define a function. Let's go ahead and call it get sonnet page. We'll call it download sonnet. And we will accept the sonnet number, which is some integer in, and we'll that. Actually, I should probably do it more idiomatically in current Python, which will look like this. Fantastic. And let me pop on GitHub Copilot. It's probably going to be useful while we implement this. Cool. And now I want to do some HTML parsing in Python. I think it was Beautiful Soup, actually. Let's go ahead. Okay. Let's see if I have Beautiful Soup installed. Looks like I do. Looks good, and we'll go ahead and print soup to see what we have going on over here. No module BS4. I'm using Python 3.10, interesting. Okay, let's try running this again. Fantastic. So it looks like we get it, and looks like we have the sonnet over here. And this is the sonnet body right here. So we can see that we're looking for a paragraph with ID sonnet text, and then we want the contents of everything inside of the M tag. So let's go ahead and add a comment. Okay. Fantastic. That should be good enough. Let's go ahead and print sonnet body. Looks good. Now we want every M tag inside of this. Let's see. I'm able to do interesting. Just providing type annotations. Let's see. We have some breaks. I guess I'll go ahead and test this out. I didn't know this functionality existed. Yeah, that doesn't look like it's too useful. So we'll continue forward. We want to get child elements. Is it really find till I see this? And we're looking for LMs. Let's go ahead and just look at the first one real quick. Interesting. Yes. Let me not apply. There we are. Fantastic. I would like to remove the tags. Find it odd that they're included by default. I already know I'm inside an M tag. That looks good. Checking for a couple options here. Looks like the solution I'm interested in is the Find Children option. see. Let's see, we're looking for find children. That's not what I want. Is it tied to this find all call? Or is this equivalent? Odd. So it seems to me that find all is not returning what I'm interested in. Yeah, it returns a definitive page element type. I guess it's because it has no children. I'm just interested in the body. Maybe there's just... Well, I'm being recommended text, so let me try it. Yeah, that was it. Maybe I should listen to GitHub Copilot suggestions. Fantastic. Things are looking good, and let's go ahead and define the sonnet body. We'll go ahead and join with a new line. And then we'll return sonnet body. And look at that, we have a sonnet downloaded successfully. So let's compare this to the implementation I had way back when. This looks like it's 10 lines total, and while lines aren't necessarily a measure of value, I think this will be much more interpretable than my original one. You can see my original one is a bit shorter, but I have a bunch of replacements existing. I have some weird regexes that are hard to interpret nowadays. And overall, I think this is a little bit more robust. So let's go ahead and get a bunch of sonnets. Right. And I'm not sure what these numbers I provided, because you can see that I do this over here. I have no idea the significance of 130 to 155, because you can see that Sonnet 1 is available. Let's look at 130. Yeah, I'm not sure what the difference here is, why I had that arbitrarily hard-coded, but I'm going to go ahead and go from 1 to 155, and let's see if 155 is the upper limit on sonnets. 156 is gone. And it looks like we're missing a lot of things on the tail end there. 153, 154. Looks like my off by one error on interpreting. 155 is indeed, there's nothing at 155. Cool. So that means we can go on this range here. Let me just check they don't arbitrarily have a 0th sonnet. They do. This is interesting. Is this equivalent to Sonnet 1? Not 155. So from Pharaoh's creatures down to Eat the World's Dew. Let's look at When 40 Winters. Huh. What do you know? 0 takes you to everything. I didn't discover this back then. So we can directly, rather than visit a bunch of pages, let us just get 0. Took a second to load, yeah, but there we go. Alrighty, and I think I will rename this to Sonnets from website, and then we'll go ahead and say this will actually be download sonnets. So we'll put that here, and with looks good. And you can see that I write to the file here. I don't know why I do this arbitrary pathing, but we can dump all the sonnets into one flat text file. And that looks good. And then we'll go ahead and drop if name equals main, download sonnets. And let's just test that this works. And we can see that it does. Fantastic. You can see that it's in this directory over here rather than the poem rewrite directory, because this is our current operating directory, but I think this will be fine. Cool. So let us refactor this into Sonnet downloader, and I think I can actually move everything here in. Because this is all just here. This is like an alternative main document, right? Unknown for navigatable string. I know that this is working successfully, so I'm going to go ahead and suppress the type there. Cool. So that's it. That's collecting the poems, and we'll move this over to main on what we have left to do. So analyze the poems, generate a frequency dictionary. So let us go ahead and create a file for markov.py, and this will generate our frequency dictionary. So we'll definitely just start off by saying so yeah, we want to tokenize the text, and a key thing about tokenizing is taking words and just getting the words. We want to cut out all symbols, we want to cut out hard stops, while we want to make sure that hard stops are respected as actual hard stops and nonsense continuations. And yeah, so let me think about this for a second. We want to make sure when we're doing our frequency analysis that we don't think the last letter of one sentence the last word of one sentence is followed by the first word of another sentence. Or do we? It's tough. Because the way sonnets are written is, yes, it's only natural in some cases that a word follows after another word, even if there's a sentence break between them. And we're only concerned with the pattern between these two. But we want to make sure to coerce a lot of these words into similar things, right? If the capitalization for two words is different, or one word is line broken with a hyphen, we want to consider that the same word, right? So we want to remove hyphen type things, right? We want to make sure that a word is represented as a word. So what I'm going to do when tokenizing something is I'm going to make sure that everything gets cast down to lowercase, and I'm going to remove extraneous symbols, possibly, like I'm seeing these parentheses here, and I'm not sure if that's something that I want in the final generation. But overall, I'm just going to bias towards making less modifications to the sonnets and try to keep the data as pure as possible and only make changes when absolutely necessary. So what I'm going to adjust right off the bat is I'm going to cast everything down to lowercase. I think that's going to make it easier to work with. Okay. And then since I'm going to be iterating on the script, how do I want to handle this? Yeah, so I'll go ahead and import random here. Okay, yeah, sure, let's try that. Fantastic. So I want to actually, yeah, we need to provide in the Sonnet downloader tool a way to we want to local sonnets. Excellent. Yeah, that's good. I'm interested in getting auto-completion. Looks like we don't get that. And it looks like we are here. So I'm going to run this a couple times because I just want to take some random subsets to get a feel for what we're looking at. Let's clear this terminal. You can see that we have a comma. Overall, things are looking pretty clean. A comma appearing in the text that could throw things off. It could coerce us down like kind of low frequency pathways that may not be desirable. But overall, I think I'm going to stick with it. Yeah, it's tough. So we're going to stick with it how this tokenized function, we might make it more complex later, but let's go ahead and build up the frequency dictionary now. And now what do we want to do? That is pretty good, aside from the fact that it's a bit cumbersome due to the fact that it doesn't use the default dict implementation in Python. Let's go ahead and go from I'm just trying to think if I, you know, yeah, good, and I'm not interested in that because I'm interested in how things follow, right? We're interested not in a default dictionary of integers, we're interested in a default dictionary that produces a list. Where this list will is a list. Does it work like this? I'm not sure. Yeah, I don't think I can type annotate that. That's not well defined. Let's go ahead and see what GitHub Copilot gives us here. Yep. That looks good. Yep. And I'm interested in actually also a parameter for the frequency dictionary given word length of arbitrary, like given a seed phrase of arbitrary length. So let's say input length, and let's see if it actually writes it for me again. So for everything, it accounts for the bounds issue, it provides the key, and it appropriately makes it a hashable type for insertion in a dictionary by using a tuple. The output, yeah, we don't have anything being overlapped, and that is surprisingly good. Wow, I am honestly just like blown away. Checking things on, you can see since input length defaults to 2, we're looking at every 2-word combination for its propagations forward. Let's put it down to 1 temporarily. Interesting. Of is apparently always followed by 3 periods. I doubt that. I'm concerned about line breaks here. I'm not sure how I have that handled. I guess since I do a split, line breaks, where do I do a split? Yeah, right here. Line breaks are included in that split, so things are getting just stacked on top of each other. The end of one sonnet will bleed into the next one. That's an edge case I'll consider later. Yeah, so things are looking good. We have generated our frequency dictionary for our sonnets. We're going to stick with 1 word at a time and then move on. And now let us... Oh, apparently it wants my import to be line broken, probably because I have a really nasty pattern here where I have an import inside my actual code. But that's because Markov shouldn't actually be interested in how to fetch sonnets, right? This is a library given some any arbitrary piece of text. It just so happens that I have a testing bit of code hidden in name equals main here. What I want to do is generate an inference function, right? I have to say def look at this. Okay, infer, next word, looks good. I'm not sure about this right here. Oh wow, it is smarter than me. It makes sure to only infer based off of the properties of the frequency dictionary itself. Wow. I wouldn't have implemented it this way. Copilot did it just purely better than I would have. But I'm going to go ahead and stick with it. We infer the next word, get that choice. Cool. So let's go ahead and say, let's try and do something. Let's think. We have the frequency dictionary, yeah, and we'll go ahead and infer next word. It's looking scary. Print infer next word. It is having trouble because, let's go ahead and expand this out into a list. Looks good. So let's see, does this, yeah, it only takes up the end. That's not what I'm interested in. I guess I'll just... Cool. Let's separate these like this. Love, I love to speak of all these, for my heart. My youth their deaths, be contented when in this with lasting memory. It's a little nonsense, right? And that's probably because we have our input length as 1. Let's go ahead and test out input length 2. And let's seed with I love. I love you, dearer, yet then my eye doth view, want nothing, that the world may see my pleasure. Sometimes all full with wills, and my next self thou gavest. Let me not get carried away reading all this. I'm a little too excited. But I'm going to go ahead and drop in you right here, and check out a text input of 3 by default. Did I? Oh, I accidentally entered a Python interpreter. I love you so, that I in thy abundance am sufficed, and by a part of all thy state. Let's try and find all thy state and see how this is looking. If thou wouldst use the strength of all thy state. So, yeah, things are looking cool. Fantastic. So we'll go ahead and say def for next in words. Yep. That is good. Fantastic. How will we decide to line break though? We went to line break, looks like in general, sometimes on commas, sometimes on full stops. Right, I cleared out the line breaks, so it's a little bit tough, right? What if we tried splitting, not on when we do this here, when we tokenize? What if we only tokenize on spaces? And then when we join everything, that's looking good. That's good. The line breaks are definitely messing with the inference. You see that we're getting coerced in the same couple things, right? So I don't think that we only want to do that, right? Because a naive split maybe I love you is also too restrictive, right? It's a tough one because we need to do a lookup on the past 3 words, right? And it's hard because there's only a finite number of 3-word sequences. yeah, you can see that want and you are even next to each other. That's hard. So the seed will need to be something. Yeah, sure, let's oh wow, it's where is this in our input data? Oh, it's literally right there. So something is interestingly breaking on shall I compare thee. That's spooky looking. Let's how do we want to do this? I want to get the tokenized sonnets. Interesting. Everything looks good. That's odd. I'm surprised that it's not performing well. Maybe when you're watching, we'll be able to notice what's going on here. Let's go ahead and remove the exit for next in words. That's good. We're getting some interesting inference here. That's very cool. Alrighty. So what do we want to do now? We're getting the next in words. Yeah. So let's go ahead and move this into a dedicated file. Looking good. Cool, we have the necessary imports. So we'll have a seed phrase, and then we'll say if seed is none, what do we want it to be? We'll just do let's see, yeah, we need this to be above, because we want the frequency dictionary, and we want a random key. We want to select a random key. I don't think I need to expand this out. Do I actually need to? Does it expect a list? Looks like it does. I'll play nicely. Yeah, that looks pretty good. Copilot once again saving the day for me. Cool. Now, effectively, what we want to do is that's pretty much what I want to do. So something interesting is going on here. Yeah, it's seeding at the beginning of each line. That's incorrect. I took this code to be given. Should not do that. The seed should only seed on the first line. This is potentially since we might have a lot of things, but it's fine for right now. I'm writing just simply buggy code. I need to decide on when to line break after the fact. I have to just generate a bunch of words. That's good. Now we don't actually want to do this. So once we have the words, I'm interested in chopping when we have full stops. So let's say that's good. We have our list of words. Now let's see. Yeah, we definitely want the random in here. So I'm just trying to find a nice way to line break at good times. I want the termination odds to be something like I want odds. So this is how many words we are in excess. And we'll just multiply it by 1/3. So basically, I'm just trying to find something to make it like we break up the lines a little bit here and there, not just always at exactly some number of words, not never. Cool. Let me think this. We actually want it to be 0 for a while. Let's see, So of course I'm injecting my own behavior by doing this, but I'm the one writing the code. Cool, so we have our odds of stopping. Oh yeah, we already have our word list. We're just determining on when to break. So I'm just thinking about how I want to actually implement this. Just taking a bit of thought here. Yeah, that's what I'm interested in. Now, what's our criteria for extending in the end? Interesting. Oh yeah, this is just the odds of stopping. We want to stop at a full stop. should semicolon be a full stop. This is looking good to me. Alrighty, let's take a look at what we have. Heavy Saturn laughed and leapt with him, yet nor the past, for thy hand willst my poor beast then find, when swift extremity can seem but slow? Then should I spur, though mounted on the ground, and yet this thy praise cannot be so bold, although I swear it to me, this told. I joy, but then my thoughts, far from where I abide, intend a zealous pilgrimage to thee, my life, saying, not you, poor soul, the centre of my faults, thy sweet virtue answer, not thy so. They that level at my mistress's eye, the little love god lying once asleep, laid. It really hits deep. I'm gonna go ahead and push this to GitHub. Git status. Let's see. How do I want to handle this? Because it looks like Git is inside of there. I'm going to handle this off video. Thanks for joining me on this ride. I know it's a longer one. Hopefully this interested you. Let me know. Thanks.